Hello, everyone, and welcome back to the channel. We have talked about caching before and how crucial it is for speeding up our applications. But how does the data actually get into the cache and stay up to date? Today, we are diving deep into a specific and very elegant caching strategy, which is read through caching. Think of it as an invisible helper that sits between your application and your database, intelligently managing data retrieval and caching without your application needing to know all the details. It's a pattern designed to simplify your application code and keep your cache fresh. So let's explore. Let's explore how it works. So first, we will talk about what is read through caching. In a read-through caching strategy, your application interacts directly with the cache when it needs to retrieve data. It doesn't talk to the database directly for reads. There is some flow. There is a specific flow. So first, your application requests a piece of data from the cache. The cache checks if the data is available. If the data is present, that's called a cache hit. The cache immediately returns it to the application. It's quite fast and simple. If the data is not present, we call this a cache miss. Here is where the read-through cache magic happens. And instead of application then going to the database, the cache itself takes responsibility. The cache retrieves the missing data from the underlying database, which is the source of truth. Once it's retrieved, the cache stores a copy of the data locally, populating itself, and then returns it to the application. The key difference from other strategies like cache aside is that the application logic is simpler. It just asks the cache, and the cache handles the heavy lifting of fetching from database on a mess. Okay, so let's try to understand how it works in details. So we have the application. Okay, where is the pen? Yeah, we have an application. Okay, the application will create a request. Like your application code needs to say, we need a user ID for user profile for ID 123, and it will make a calls for the cache. Okay, so it will make a call for the cache to get, for example, a user by the ID, and the user ID is, for example, 123. Okay, let's talk about cache hit scenario. The read-through cache, okay, the read-through cache checks its internal storage. If the user 123 is already there and it's not stale, we will talk about staleness later, okay? It grabs that data immediately and returns it to the application, okay? So this is when we have a cache hit, okay? If we have a cache miss, if basically this user is not available in the cache. So if user 123 is not in the cache, that's what we call this a cache miss. The cache fetches the user from the database. Okay. So again, now the read-through cache doesn't just tell the application, nope, we don't have the data. Instead, the cache itself initiates a read operation to the primary database. It essentially says to the database, hey, I need user profile ID 123. The database will respond. The database process this request and sends the user profile data back to the cache. Okay. After that, the cache will store the data. The cache takes this data, store it in its own memory, like Redis or Memcache, associating it with the key user 123. This often called populating the cache or filling the cache. And after that, the cache, when the cache is finished, it will return the data to the application. Like finally, the cache returns the freshly received and new cache data to the application. From the application's perspective, it just made one request to the cache. This interaction with database on a cache miss is abstract way by the read-through cache implementation. Okay. Okay, let's talk about the advantages. of read-through cache. First, we will talk about the simplified application code. This is a big one. Your application logic doesn't need to contain code for checking the cache, then falling back to database, then manually populating the cache. It simply requests data from the cache. This makes your application code cleaner, easier to maintain, and less prone to bugs, related to cache management. Number two, lazy loading of data. That is only loaded into the cache when it's actually requested by the application and isn't already present. This means your cache isn't filled with data that might never be used. Optimizing cache memory usage, it's loaded lazily on demand. Number three, data freshness on mess. When a cache miss occurs, the data is always fetched directly from the source of truth, which is the database. This ensures that the application receives the most up-to-date data at that moment, and that fresh data is then populated into the cache. This helps reducing the chances of serving stale data immediately after miss. Lastly, we have potential for strong consistency with write-through cache. Read-through caching often pairs very well with write-through cache strategy for updates. If writes also go through the cache and then to the database, you can achieve a higher degree of consistency between the cache and the database. Okay, let's talk about the disadvantages for the read-through cache. The first thing, it's initial latency on cache miss. Like the first time a particular piece of data is requested, when it's not in the cache, the application will experience higher latency. This is because it has to wait for two hops. The cache to miss, and then the cache to fetch from the database. This is inherent to any lazy loading approach. Number two, cache provider dependency. The read-through cache logic, how the cache communicates with the database, is typically implemented by the caching provider or library that sits on top of a generic cache. This means you might be more tightly coupled to a specific caching solution that supports this pattern. Number three, database load on multiple misses. If many different uncached items are requested simultaneously, like for example during like a cold start of the application, or if many new items are accessed at once, the cache will issue multiple requests to the database. This can still put a significant load on the database, similar if the application were hitting it different for those misses. Strategies like cache warming can help mitigate this. And lastly, complexity in the cache layer. While application code is simplified, the complexity of interacting with the database is now shifted into the cache layer itself or the caching library. This library needs to be robust and handle database connections issues, timeouts, etc. Next, we will talk about when is read-through cache a good fit. Read heavy workloads, I guess. This is the first thing. Like most caching strategies, it excels when your application performs significantly more read operations than write operations for the data being cached. Number two, simplified application logic is a priority. If you want to keep your core application code clean and delegate cache filling logic, read-through cache is quite excellent for that. Number three, acceptable latency on first access. If a slightly higher latency for the very first access of a piece of data is quite acceptable in exchange for fast subsequent access and simpler code. Number four, data that doesn't change extremely frequently. While it fetches fresh data on a miss, if the underlying data changes very rapidly, you will still need effective cache invalidation strategies in place to avoid serving stale data from cache hits. The read-through pattern, its primary addresses how data gets into the cache on a miss. Yeah. Okay, next thing we're going to talk about pairing with other strategies. It's important to remember that read-through caching primarily defines how data is loaded into the cache on a read miss. It doesn't dictate how data is written or updated. So if we want to talk about writes, you'll still need to decide on a write strategy with read-through cache. You might use like write-through caching, where writes go through the cache and then immediately go to the database. It's common partner for the read-through cache. It helps maintaining consistency. Alternatively, you might use a write around strategy, which is write to go directly to the database, potentially invalidating the cache, or write back, which is write to go to the cache and or written to the database later. Next, we're going to talk about some cache eviction. I forgot to put in here, so let's put here. Cache eviction. So you still need to use cache eviction policies like LRU, LFU, or TTL, like time to live, last read update, I guess. I will talk about cache eviction policy. I'll create a video about them. Basically, you need them to manage the cache size. Read through doesn't basically solve this. It just determines how data is loaded. That's only. So you need to use cache eviction policies. Also, you need to use cache invalidations, like if data is in the database can be updated by means other than through a write cache strategy, for example, like another service updates the database directly. You will need a separate cache invalidation mechanism to ensure the read through cache doesn't serve the stale data on hits. Okay, so in conclusion, read through caching is an intelligent and application simplifying strategy by empowering the cache itself to fetch data from database on MS. It streamlines your application code and ensures that data loaded into the cache is fresh at the time of retrieval, while introduces a slight latency penalty on the first access and shifts some complexity to the cache layer. Its benefits in code clarity and automatic cache population make it a very attractive option for many read heavy applications. So yeah, that's it for this video, and thank you for watching this video, and see you in the future.